Atomic and Nuclear Structure. Written by the PET-CT Training Institute. All matter is composed of atoms. Atoms, in turn, are composed of the following: electrons, protons, and neutrons. Properties of atomic particles. Protons have a +1 charge. Neutrons have no charge. And electrons have a -1 charge. Electrons are approximately 2,000 times lighter than protons or neutrons. The atomic number, Z, represents the number of protons in the nucleus of an atom and determines the chemical identity of an atom. The mass number, A, represents the number of protons plus neutrons in the nucleus of an atom. This demonstrates how the A and Z numbers are typically written with X representing the element. Isotopes are forms of an element having the same number of protons, Z, but different numbers of neutrons, thus chemically identical, but with different weights. Take for instance protium, deuterium, and tritium. They are all hydrogen molecules, except with different numbers of neutrons. As you can see, changing the number of neutrons, while having the same number of protons, creates isotopes, but also creates nuclear instability causing radioactive decay. As previously discussed, all isotopes are not radioactive, but all radioisotopes are radioactive. A more commonly used term for a radioisotope is radionuclide. Radioactive decay refers to the spontaneous emission of radiation, particles or photons, from the nucleus of an unstable atom. This decay is referred to as a disintegration. Radioactive decay is a totally random process. We never know when a radioactive atom will emit its radiation. We can only discuss the probability of decay. Not all radiation is emitted from unstable atomic nuclei. Photon radiation, electromagnetic radiation, or light, may be emitted as a result of electrons falling to fill vacancies in lower energy atomic shells, known as electronic transitions. This diagram demonstrates an electron moving from the L shell to the inner K shell, releasing the difference in shell energy as a photon. When photon radiation originates from outside the nucleus as a result of an electronic shell transition, the photon is referred to as a characteristic X-ray. The term characteristic is used because the energy is characteristic of the element from which it originates. What is the difference between an X-ray and a gamma ray? There is no difference between an X-ray and a gamma ray except for their origin. X-rays originate from outside the nucleus, while gammas originate from within the nucleus. Energy relates to penetrating power. The SI energy unit is the joule, but this unit is much too large to use with radiation. This is how joules and electron volts relate to each other. You can see that the electron volt is much smaller. keV and MeV are more commonly used to describe photon energy. This is a quick comparison of energies of different radionuclides used in imaging. One MeV represents the energy required to lift a mass of 1 milligram through a vertical height of approximately 1.5 millionths of 1 centimeter. This represents a very small amount of energy on the macroscopic scale, but a large amount of energy on the microscopic and atomic level, large enough to produce ionization events and break chemical bonds. The last few slides are examples of the energies of radionuclides we use. Thank you. Please play back the video as often as necessary to understand the concepts. Write down any questions you may have, so the PET-CT Training Institute may answer them.